going live on the camera, just so you know. Okay, live is the wrong word. I'm recording on the camera. Actually, it's. All right, everybody, pull out your worksheets from yesterday, your teamwork exercise. You'll be grouping up in a little bit, okay? Who wasn't here yesterday? Anybody else? Okay, so you're going to be with this group of 3 guys right here, okay? When the time comes, also. These 3 of you. Okay. Take one, pass it. All right, in a couple minutes, we're gonna go back into that and finish that, and then I want you to present it to the class. By present it to the class, I mean present to me. But before that, I'm passing out a couple of worksheets, which we're going to be going over today and tomorrow. No. Alright, so for right now, what I'm going to do is give you a very quick lecture, and I want you to fill out worksheet 4-2, okay? So, we're finally going to write down what I've been telling you about, which is the teleological argument. I'm going to write down a couple of things we talked about yesterday, but I'm going to say them again because repetition is the key to knowledge, and also because I wasn't recording before. So, let's go over this argument. Teleological argument. Here's how it's written. So go ahead and write it down on your worksheets. Major premise. Every design had a designer. Minor premise. The universe has highly complex design. Therefore, the universe had a designer. Okay, so go ahead and write that out. Any questions about that? All right. So yesterday we went through, or obviously we started our little project here, where you picked one concept or thing from the universe, from the cosmos, from space, and you're going to argue for why you think it has design. Now, what was your group? What did your group pick? What this group right here? What did you guys pick? You got Lonnie with you, right?
The sun and the turtle shell.
Oh, the turtle shell.
The sun, and then the second one, which was from biology, was the turtle shell. Okay. And what did you guys pick?
Gravity and the oxygen.
Gravity, and then the ostrich egg. Orbit of the Earth, and the human skeleton. The human skeleton. You guys.
Moth and the atmosphere.
Okay, moth and the atmosphere of Earth, right? Okay, so I asked you when you were doing that, what kinds of things are you looking for when you're looking for quote design? What makes up design? Something has to be complex. Okay. Yeah, extreme improbability. That was one of them. It seems like thought was put into it. Okay. All right. So here were the two main criteria, and it's from a guy named William Dembski. Excuse me. He was the one who studied this, and he wrote a book called The Design Inference. He was trying to figure out what it is that makes rational creatures, rational beings, what it is that we are able to recognize in things that have been designed. Like, how are we able to recognize other rational beings at play or at work? And the two main criteria he came up with were, number one, extreme improbability. So this is number one on your worksheet there at the bottom. Okay. Extreme improbability was number one. In other words, it's very, 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 very unlikely to happen unless some mind is behind it. Okay? All right, the second one, after extreme improbability. An independently recognizable pattern. What do I mean when I say independently recognizable? Anybody? Means we would recognize this pattern in a different context. Okay? So the big example we gave was this Mount Rushmore. So we would recognize these faces in other situations, right? In other contexts. I'm going to bring it back. But we would recognize these faces in other contexts, right? On money or in textbooks. Yeah. Okay, so that's part of it. He also, the second one, he doesn't just say an independently recognizable pattern. He also uses the term functional requirements. Any idea as to what that might mean? Think of it. What is function?
It does purpose.
Purpose, it does something, okay? So what is a requirement? Working on our reading comprehension today. Okay. So if you have a requirement to fit a function, it means you have the ability to do what you're supposed to be able to do, right?
Yeah.
So think of it this way, and you might want to write this part down. There, number 2. Small individual parts working together toward the same function. And you don't even have to use the word small. You can just say individual parts working together toward the same function. In other words, you've got separate systems, separate patterns, but they're all working together toward a similar function. So again, back to this. You've got different patterns working together. You've got the shapes that make up George Washington's eye, and his other eye, and his brow, and so on, right? You've got all these little patterns and intricacies, but they're all working together to create an image, right? Kind of like pixels in, on a picture or on a video screen, okay? So this is the idea that we are able to spot design when we can see, number one, it's extremely improbable. But that's not enough by itself. Number two, we also are able to see that different parts are working together toward the same function. Okay? So when we talk about the universe, for example, we say the universe is designed for life. What we mean is that, number one, it's extremely improbable that the universe would come about to support life in the way that it does by only natural processes. And then number two, we're saying that individual parts of the universe are working together to make sure life is possible. So that we're going to look at some of those examples. Of course, I showed you pictures of different rock formations. And this one, it's extremely improbable, but was it caused by natural processes?
Yeah.
Yeah, why? Erosion, flooding.
Because like everything else around it looks like it was naturally formed. They all have the same kind of texture.
So are you saying it fits in?
It fits into the scenery.
Okay.
It took a long time to make like the whole geographical area like all look the same. And
Yeah, so it fits in, okay. I think the other thing is we don't see the second part to it. We see an extreme improbability, but we don't see any function really. Not really. It's not creating an image that it's if someone did this, it's like abstract art. It's not like creating an actual image, right? So here was another example. This one, it looks like an elephant, but does it look enough like an elephant for us to come to the conclusion that it was designed? No, probably not. Okay, looks like a natural formation.
it's in the natural.
Same thing with this one. Even though it's very improbable,
It looks weird.
it does look weird. This is Devil's Tower. It's in Wyoming.
I saw that.
It's really big. Why do they call it that? I'm not sure.
It just looks like a melting like. It looks like melting wax.
Interesting. But yeah, it's just a giant rock. Okay. And then we had this one, of course. This one looks like a skull. Most people would say they're pretty sure it's only caused by natural processes. It doesn't look quite enough like a skull for us to say definitively that it's designed, right?
Yeah, and everything else around it looks like
And then this was our final example. And you can barely see it, perhaps, but it says, "Welcome to Victoria," and these are flowers planted in that arrangement. Okay, obviously this is designed because you've got the individual parts, meaning the individual flowers, creating individual English letters, and then when you even combine that further, it becomes a phrase, right? So of course, this is design. And so this is the idea I want us to understand, that when we're looking for design, we're looking for extreme improbability, and we're also looking for individual parts working toward the same function. Okay, that's how we can say definitively that it's design. Think of it this way. If something happened through only natural processes or chance, it's very unlikely that one chance happens over here and another chance happens over here, and then somewhere along the way they start working together perfectly, right? You see what I'm saying? So we're going to see so many different functions in the universe that are working together, and that's what causes us to think they're designed rather than happening by chance. Okay, and then of course the unlikelihood really adds to the argument. Okay, so I'm going to stop the recording now, and you're going to continue with